Okay, so this is number 4 on practice 3. So ideally you've tried this yourself first. If you've not yet tried it, you should do it yourself before you watch me do it, okay? Because it's not as good if you just watch me do it. You need to do it yourself, okay? All right, so a 78 kilogram skydiver has a speed of 62 meters per second at an altitude of 870 meters above the ground. If 500,000 joules of energy are dissipated during the fall due to air resistance, with what speed will the skydiver hit the ground? Okay, so first thing is we need a little sketch, which is becoming difficult on this little paper, but so I'll try to, I don't know, squeeze it in down here, I guess. I don't know if you can see this if I write here, no. Okay, all right, so we have a skydiver. I don't know, this is hard to draw, whatever. Looks like a bug, well, whatever. Okay, 870 meters above the ground. Okay, and he's moving at this point. It says he has a speed of 62 meters per second. Okay, and we want to know with what speed will he hit the ground. Okay, so when it says this, it doesn't mean after he crashes into the ground. It means just right before he hits the ground. Okay, because obviously after he hits the ground, it would be all ED because nothing else is happening. Okay, all right, so at position A, when he's in the air, we're going to ask ourselves the question. So EG, is he above the ground? Yes. Okay, EK, is he moving? Yes. Are there any springs stretched or compressed for EE? No. Okay, and is there any energy dissipated by friction? No, never in position A because nothing's happened yet. It can't have had a chance to heat up anything because nothing's happened yet. Okay, so position A is at 870 meters and then position B is at the ground. Okay, all right, so let's see what kind of information we have. So we know the mass, we know the speed, and we know the height, okay? It doesn't tell us any of the joules over here. It doesn't tell us any of the energy. So that means we're gonna have to calculate all of these things, okay? So let's just start with the speed. So the kinetic energy is gonna be 1/2 times the mass times the velocity squared, okay? And again, I'm not putting the units because I don't have space on here, but if you can, you should, okay? But it's really hard to write with the tablet as is, okay? All right, so I'm gonna have 1/2, okay, times 78 times 62 squared, okay? So that's 149,916. Okay, and if you want to round it, that's cool. That's fine with me, I don't care. Okay, round to 150 if you want. All right, don't forget to square this, okay, because this is the biggest mistake here is not squaring. Even if you write it, people forget to square it, okay? So just be cautious of that, all right? Okay, I also know he's above the ground, so I can find his EG, which is his mass, which is 78, times G, which is always 10 newtons per kilogram because we're on the Earth, okay? And his altitude is 870 meters, all right? So if we smash all these together, 78 times 10 times 870 is 678,600. 678,600 joules. Okay? All right. Please make sure you're punching this in your own calculator because if you don't, we might not know that you have a problem using the calculator. Okay? So make sure that you don't just write my answers. You need to do it yourself. Okay. All right. Now I see all these energies. So now if I add them all up, I can get the total. So I've got 678,600 plus 149,916. Okay. Is going to, whoa, that was really bad. Whoa, that was really bad. Hold on. Oh my God. Okay. I guess it'll have to be like that. Oh, I just got this new tablet. Okay. So the total energy is 828,516 joules. And again, if you want to round it, that's cool because that's kind of a long number to write. 516 joules. Okay. All right. So when I fill in my chart, I can see about 150,000 is kinetic and about 700,000 is total, right? So if I kind of do a little fraction, 828, it looks like about 80% of it is EG, okay? So I'm going to fill the EG up a little over 3/4 of the way. Okay, and that's only going to leave a little bit of a quarter for my EK, all right? So there we go. My EK is maybe a little less than a quarter, okay, and my EG is most of the pie, all right? Okay, now I know the total energy is the same because that never, ever, ever changes. Once you find the total somewhere, it's there for all of them, okay? All right, so I've got 828, 516 joules of total. Okay, so let's look at him in position B. Is he above the ground? No. Is he moving? Yes, because he has not quite smashed into the ground yet. It's this tricky place where he's on the ground, yet not on the ground, okay? Any springs? No. Dissipated? Yes. It tells us 500,000 joules of energy are dissipated, okay, in the air resistance, okay? So this one's 0. This is 0. So if I have 828,000 total and 500,000 are going to the ED, that only leaves me 516 minus, I should be able to do this in my head, 328, 516 for the EK. 328, 516 for the EK. All right, so now we can figure out how fast he's going. So if I use EK equals 1/2 mv squared, okay, the energy is 328, 516, okay, times 1/2 times his mass, 78, times v squared. Okay, 516 equals, and I'll go ahead and divide by 2 first. You can do it anyway. It doesn't really matter. You can move it first and then divide. It doesn't matter. Okay, then I'm going to divide by 39 on each side. 328, 516 divided by 39. Okay, that gives me 8423 for v squared. That seems awfully big. Okay, and then I'm going to take the square root of that, and then I've got 92 about, 91.77. 92 meters per second. That's pretty fast. Well, I guess that makes sense, right? If he's fallen from an airplane, that's pretty fast. Okay, so when he hits the ground, he's going to be going 92 meters per second. All right. So if I look at the ratios now, the dissipated energy, 500,000 to 828, that's more than half, right? So it's a little more than half of it is ED, okay? And then that leaves the rest of it for EK, right? And the total here is still 828, 516. Okay, so I've got, let's see, a little more than half or so is going to be ED. The rest of it's going to be EK. All right, now these don't have to be perfect, but they should look pretty close. Okay, if you want to be really technical and awesome, you could like calculate the percentages and write them up here. That would be totally stellar. But, you know, that's like above and beyond. Okay, that is all.